This LOS is distinguished between discretely and continuously compounded rates of return and calculate and interpret a continuously compounded rate of return given a specific holding period return. Continuously compounding. An important concept is the continuously compounded return associated with a holding period return, such as when you're looking at time 0 and then time 1. The continuously compounded return associated with a holding period is the natural logarithm of 1 plus that holding period return, or equivalently, the natural logarithm of the ending price over the beginning price, the price relative. Because remember, holding period return was the ending minus the beginning divided by the beginning, and plus any dividends if you had any dividends. Or you could do ending divided by the beginning minus 1, of course. So that's what they're just saying. That's recall the holding period return. So the continuously compounded return is 1 plus the holding period return to the log normal. Okay. So here's an example. If we observe a 1 week holding period return of 0.04, so 4%, the equivalent continuously compounded return, called the 1 week continuously compounded return, is log normal 1.04. So how do we do that on the calculator? 1.04, and we just hit the log normal, and we've got 0.039221. Okay, so the 4% 1 week holding period return is equivalent to a 1 week continuously compounded return of 0.039221, or 3.9221%. Okay. So €1 invested for 1 week at 3.9221% continuously compounded gives us €1.04 at the end of the 1 week. So another little example here, if the 1 year holding period return is 9%, then the continuously compounded is log normal 1.09. So 1.09, and we hit the log normal key, and we're going to get 0.086178, so it's 8.618%. Okay, and just so to convert back and forth, if I clear the calculator, if they gave you the continuously compounded rate of return, how do you convert it back to a holding period return? Well, I gave you the keystrokes down here for you on that. So let's just use that same example. If it was 0.08618 was the continuously compounded, we do second e to the x minus 1, and we'd have our 9% holding period return. Okay? Okay, carrying on with our continuously compounding. So we have here the log normal of the ending price divided by the beginning price is the same as the log normal plus the holding period return. Okay, so our current stock price S0 is a known quantity and it's non-random. The future price, such as S1, is a random variable. So the price, that's a price relative, S1 over S0. S1 is the ending price and the beginning price is S0, and it's equal to 1 plus the holding period return. Fine, so that's just what it's saying. Ending divided by beginning equals 1 plus the holding period return. So just a quick example, if your S0 price was $30 beginning, ending price is $34.50, then S1 over S0 would be $34.50 divided by 30, which equals 1.15. If we subtract 1, then we know our return is 15%. Okay? So this is just saying that in general, price relatives have the form. They're just saying that the ending price is ST plus 1 over S over T. And so that equals 1 plus the return T plus 1. Okay? So we're just using rate of return from T to T plus 1 rather than T0 to T1. Okay? That's just a different presentation or a different nomenclature. So down here, we're just going to have another look that the log normal of the ending price divided by the beginning price is the same as the log normal of 1 plus the holding return. So the log normal, 34.50 divided by 30, log normal 1.15 is 13.9762%. So let's just do that. I'm going to do it slowly on the calculator. 34.5 ending price divided by 30 equals our beginning price. So we have 15% holding period return, okay? If we hit the log normal, that's going to give us our continuously compounded rate of return, which is 0.139762. So that's 13.98%. It's been rounded, okay? And so the continuously compounded return is smaller than the associated holding period return. If our investment horizon extends from t equals 0 to t equals t, then the continuously compounded return to t is the log normal of ending divided by beginning. And that's the last slide for this LOS. Thank you.